Good afternoon. Am I audible? Hello, can you guys hear me? Okay, so today's lab class, we will do the program to implement STEM. So this is the program. STEM. So what's the main operations of STEM? So what are the main operations of STEM? In STEM, basically we have two main operations. Push to add items in the stack, pop to delete an item from the stack, and apart from that, we can check the top element of the stack, and we can also traverse the stack. Okay, so in this program, we are going to implement the stack. So as you guys already know, stack is last in first out data structure. So I need to derive data structure. Therefore, we can implement it with the help of an array. So these are the normal libraries. So here I am initiating a stack with size 5. Okay, you can just take a normal array. And the size is 5. Stack is also limited size. Correct? So your stack size is 5. That means at most I can add 5 items only, or I can store 5 items only. Okay. So apart from that, I am prototyping some of the programs, functions, push, pop, traverse, is empty, top element. Apart from that, there is a global variable top equal to 0. So this is the main indication or the counter or your pointer, which will keep track of your top values. Remember, in theory classes, I explained initially when stack is empty, we initialize with -1, then we increase the top value, then we add items. So same thing. Programmatically, we just initialize it to be the 0. That means your stack is empty or the pointer is at 0. Okay. So inside the main function, there are two variables, element and choice. So for all operations, I'm giving options to the user. First is for the push operation. That means you want to insert something into stack, then you want to delete from the stack. That means pop operation. That you want to print the top element of the stack. Then you are going to check whether the stack is empty or not, and also traverse the stack. That means what are the elements in the stack. Okay. So if you notice here the following, it's an empty. I didn't provide anything here. No initialization, no implementation or documentation, or no comparisons. Why? Because here I'm giving the choice to the user. So this loop will run for indefinite time. Okay, so when you provide a certain condition in your code, for example, I less than equal to 5 or 6, it means that piece of code will run for 5 times, maybe 6 times, or 10 times, depending on the condition you provide. Here, I didn't provide any condition. Okay, no initialization, no condition, no implementation or documentation, because this portion will run for indefinite time depending on the users. Okay, so therefore you can see there is an exit option too. So when user wants to exit from the program, then only it will stop. Okay. So here I'm asking the choice from the user. So then we have used a switch case. So using the switch case, it's a bit easier to provide all the menu or the options to the user. So case one. What is the case one here? We want to push something. We want to add item into the stack. So in case one, remember, for pushing an operation, we always check whether it is overflow condition or not. Overflow means your stack is already full and still you want to add something. So before push operation or inserting anything, we are going to check whether it is the overflow condition or not. Therefore, top equal to 5. Because maximum size is 5. Right? So if it is so, so it will just print and add. Else, you can just add the items, whatever items you want to add into the stack. So after that, it's calling the push function. Okay, here you are calling the push operation. Okay, so next is 2. 2, you want to delete operation. That means pop. So for pop operation, we always check the underflow condition. Right? So if top equal to 0, that means stack is empty and you cannot delete anything from that. If you are still trying to delete, that means it's an underflow condition. So after that, else you will simply call, you are calling the pop function. Okay, and it will also show what is the item you just deleted. Okay. Next, 3. 3 means print top element of the stack. You want to print the top item of the stack. So here, 3 means it's checking whether it is empty or not. If it is not empty, that means it will simply show the top element. So here I'm calling two functions, is empty and top element. Next, if it is not, then it will simply print that stack is empty. Then case 4. What is the fourth option here? Check if the stack is empty or not. So in case 4, I'm just calling the function is empty. If yes, it will print stack is empty. Otherwise, it will show it is not empty. What is the case 5? 5 is the traverse stack. So 5, here I'm just calling the function traverse. And 6 is the exit. So in case 6, just exit. Okay, now we are defining all these operations. So what are the functions you have prototype earlier? Push, pop, traverse is empty, top element. Right? So for push operation, that means you want to add. What we do is simply add the value onto the top item of the stack. Then we increment the counter. Okay, just add the item, value will be at the top. We always, it's the last in first out, that we can do insert delete at top only. So stack top, we are just inserting the value. So after adding the value, we are just incrementing the counter. So next time when you want to add something, again you will add the item, then you will increment the top. Top is the pointer. Okay. Next, pop. Pop, what we do? We decrement the counter first, then we return the top item. Right? Same thing I explained in the theory class. Then traverse. What traverse does? It simply print all the values stored in the stack. So first I'm checking whether top is 0. If yes, it will simply print that stack is empty. Otherwise, if there are some items stored in the stack, then it will print the item. So how will it print the item? Because it's a top down, right? We write the top item first, then we go to the bottom part. That's why the counter here we have started from top -1. Okay, and stop -1. Then you will do this thing until you reach the bottom. That is top equal to 0. So for that, you will keep implementing and it will just bring all the items stored in the stack from top to the bottom. Okay. Next function is the is empty. So is empty, what it does, it will check whether top item is 0. If top equal to 0, that means return 1, means it's true. it is empty. Otherwise, it will return 0, which is false. And how we are returning the top element? We will simply return the top element, which is top minus 1. Since it's like the pointer goes from 0 to 5, so top item will be 5 minus 1, which is 10. Okay, so if we run this, so it's giving all the options. So enter the choice. So first I want to add. Okay, there is nothing here, correct? So suppose I want to delete an item. Okay, so it's showing under. Why? Because I didn't enter anything, right? The stack is initially empty. Obviously, if I want to delete something, it will show under. Okay, so now it's asking again. It will be printed over and over again until you press the exit. That is option 6. So now I want to enter 1. That means I want to push or add item. So enter the value to insert. Suppose let's enter 2. Okay. Now I want to add some more items. Enter the value. And to add more item. Enter the value. Add more item. Enter the value. Okay. Now I want to traverse the item stack. 5. You see, it's showing there are total 4 elements in the stack and the items are 7, 6, 4, 2. So if you notice, 7 I inserted the last. So it's showing at the top. Right. The first item I entered is 2. Next I inserted 4. Next I inserted 6. And the last I inserted 7. Okay. Next I want to print the top element. Okay. So it is showing the top item is 7. That's correct. Top item is 7. The last item I inserted or added is 7. So top item is also 7. I suppose and to add one more item. Let's add one. Added one more. And to traverse, now there are 5 elements. Okay. The limit for this stack is 5. Now let's see what will happen if I want to add some more. And to add more, I want to add so I entered. See, it's showing overflow condition. Okay, your limit is already 5 and I already entered total 5. Okay, so it's showing overflow condition. Now I want to traverse it. So the 5 item in the stack is 9, 7, 6, 4, 2. Okay, now I want to delete the item. So select 2. So element removed from the stack is 9. So 9 is the last element I added onto the stack. So after deleting, the 9 will be removed. Top item is 9. 9 will be removed. Right? Now you want to delete some more. Okay, now element removed is 7. After 9, 7 was the top. So 7 is deleted. Now let's see it again. So remaining elements are 6, 4, 2. There are 3 items in the stack. Okay. Now let's see if we choose 4. If stack is empty. So it will just show the stack is not empty. Okay. So that's all. Okay. There are 3 items. You want to delete more. 6 will be removed. Now if we traverse, only 2 items left. Okay. So this is the program to implement the stack with all the operations push, pop, traverse, top item. Is the program clear? I will share the program with you guys. You guys run the program and see all the possible options. If I enter 6 now, it will be exit. Okay, it's not coming. It's not showing the options now. Okay, is this clear? See, the last item we add into the stack is the first item to be deleted. So it's the last and first. So what is the time complexity for each of this operation? For push, pop and all, what was the time complexity? For push, only for this function, what will be the complexity? What is the complexity for push and pop? And top item? And say what is the complexity of push pop operation and print the top? First three. What's the complexity? O for what? For which one you are saying ON? Balsa say ON. ON is the complexity for which one you are saying? Just see what's happening here. Push, what you are doing and push. You are simply adding one item at a time. So how can it be ON? ON is the number of input. In your push operation, depending on your input size, is the push operation depending on the number of input size or number of inputs or the items stored in the stack? No, it is not. Therefore, time complexity for push and pop and checking the top item is simply O1. Yes, for push also O1, pop also O1. You are dealing with only one item at a time, which is the top item. Therefore, it's a simply single step operation and complexity for push up and checking the top item or also say speed, which is O1. But the traverse, in traverse, what's happening in traverse? For traverse, the complexity is ON. Why? You are traversing through the whole stack. There's a for loop here, right? It's a single for loop, so complexity is ON. Correct? In push, pop, and is empty. Is there anything? No, it's just single step. In push also just single step, pop also single step. So O1. But in case of traverse, there is a for loop, and anyway we are traversing through the all elements stored in the stack. Therefore, complexity for traverse is O of n. Is empty even though there is a if and else. Again, it's a single step, single step. So if you add up just one step, Okay, in last class, we did for push operation, complexity O1, top operation also O1, top also O1, but for search, order traverse is ON because it's it's basically depending on the input sides or the numbers stored in the stack. Okay, understood? Here. Say yes or no. So I'll share the program with you guys. You guys try yourself and see each and every line of the program and try to recall what I explained in the class. Okay, check each and every line and you will understand. Okay, just stop showing. Look at the numbers. Just 3.5 way of the workshop. Okay, share the program with you right now. Subscribe and share with them. Okay, thank you all. So I'll share the program in the group. You guys do and give me the screenshots and try to understand each and every line. If you have any confusion, you can go through the video again or you can ask me also. Okay? Thank you.